Welcome back to part two. We've just talked about the continental margin, the shelf, the slope, and the rise, and the abyssal plain, and shown you an example of it. In this case, the continental shelf is really wide. These are great fishing grounds, although we have primarily overfished them by far. The Georgian banks out here. Now, zooming closer, we saw the shelf, the slope, and then the rise in a submarine canyon. Now let's go from the east coast, where we have a really wide continental shelf, to the west coast. This is about the same magnification, and you'll notice the west coast shelf is very, very thin. And we have some really big canyons. What's going on? Well, this is looking from the north toward the south. Here's California, here's the Pacific Ocean. The ocean crust is subducting underneath California. Ooh, that's good subduction music. Along the way, this stuff is going down and taking with it water, melting, coming back up and creating Mount Lassen, Mount Shasta, Mount St. Helens, Mount Bachelor, the Sisters, up in Oregon, California, Washington, and all the way up into Alaska. All those volcanoes that are explosive. They're scraping off, the crust is scraping off here and creating what's called exotic terrain. Some of these weird things that are actually oceanic end up being scooted up to the edge of the continent here. So here's the ocean plunging underneath us. You can't really see it because of all the sediments covering it up. We've got to clean that up someday. Extra credit. And you end up with a trench out there. Here is what it looks like off California, and this is looking from the south to the north. In this case, it's looking from the north to the south and from the south to the north. This is off the east coast of the United States, really wide shelf, slope, rise, and then plain. Then off California, it drops off really quickly. This is called an active margin because that's where the plate tectonics are going on. This is called a passive margin because that's like the back side of the continent. Pretend like this is the front of your hand. As you scrape it across the table where nobody's dusted in a long time, you're going to collect a lot of dust on this side. On this side, it's just whatever gets left behind. Here is another example of the submarine canyon. You have an abyssal fan as opposed to an alluvial fan. Shelf, slope, rise, alluvial plain. You get the idea. Let's take a look down off New Orleans. The shelf, the slope, the rise, but something weird is happening here. All these little hummocky things, those are underwater landslides that have occurred from all the sediments that have been deposited out here. There's so much sediment that just like a pile of sand on your street, that pile of sand will slough down. Although I've got to admit, if it's a pile of sand on your street, it's probably kids climbing on it or people on bicycles and the like. It looks like there's an old canyon here, but that has mostly been covered up by all the terrigenous sediments. Now, remember we were talking about trenches? Here's a trench off of Cuba. This is really kind of cool. Notice almost no continental shelf right here because right here, this plate is plunging underneath Cuba. And it's strange, but over here, this plate is plunging underneath here, and you get all kinds of stuff going on. How do we know that? This is Haiti. Remember what happened there about 4 years ago, 3 years ago? Really big earthquake, killed lots of people. Here's why. Here's a trench, ocean plunging underneath the ocean, explosive volcanoes, lots of earthquakes, and you end up with less dense material rising back to the surface, creating all these volcanoes. Now, that doesn't explain Hawaii. Hawaii is a little bit weird. Imagine that underneath right here, there is something really hot, and it's letting hot stuff come up to the surface. But then you move the continent this way. Well, where's the next island going to come up? Well, apparently right here, and then here. If you look at the Midway Islands, they are very old. They've been worn down. They're almost nothing but an atoll. As you go this way, this way, this way, you get more and more recent lava flows and smaller coral formations. There's a hot plume under here, and the continental plate is moving this direction. If that's really happening, yeah, there should be an island forming over here, right? There's not. Well, yeah, there is. Right over here, there's an island forming. It's already been named Luihi. All you're going to have to do is wait until it rises about another 10,000 feet, and it will be above the water, and there will be a new Hawaiian island. You might want to buy land now. So Hawaii is caused by a different thing, not a trench, but a hot spot where a hot plume of magma is coming up through the crust of the earth. Other places like Samoa or Tonga are right along the edge of a trench, and here the ocean is plunging underneath the ocean. When that happens, you get the lava or magma rising, creating islands. Let's take a look at how old these islands are. We're going to go to this island right here named Tutuila. Here's the Pongo Pongo International Airport. Here is my old house, and if you take a look, there's almost no reef right next to this island. Why? Because the whole island, well, the last eruption in this area is probably less than 30,000 years ago. It also plunges very deep into the water. So you don't get really good coral formations when it's deep and when it's young. On the other hand, let's go to, well, a place where these islands have been completely worn down. Japan, Taiwan, the Philippines. Let's go right over here. I bet that's where you thought we were going to go, right? To a little area called the Marshall Islands. In particular, we're going to be looking at this and this, which are this and this. Sorry about the weird imagery, but these are mosaics. This little island is called Bikini. During World War II, we did a lot of fighting here. We kicked all the people off, we kicked the Japanese out, and we told the people, we own this now. And we started exploding bombs there. Any examples of that? Yeah, take a look at this big hole. That was from the Castle Bravo experiment, where we blew up a nuclear bomb right here. It was a bit bigger than we thought it would be. What is coral, by the way? Coral is nothing more than an upside-down jellyfish which extracts calcium carbonate from the seawater, makes its little house. They're all sleeping here. You can't see them, but here's what they're like when they're out. And this is a coral reef. There are different kinds of corals, but essentially they're just jellyfish that are upside down in their little calcium carbonate houses. Remember how water can dissolve salts? It's kind of handy. Now, where's the island here? Well, it's gone. Unlike this island, or these islands, or Hawaii, the islands themselves have worn down. And the only thing that's left behind is the coral that grew on the outside of the island. This thing here, called the lagoon, isn't very deep, probably no more than 100 to 300 feet deep. Getting ships in and out of this can be trouble. It's kind of a pain. We did it, and then we exploded the bombs and watched what happened to the boats. Let's take a look at, not Bikini, but Kwajalein. Here is a map of Kwajalein, and it's actually all kinds of little teeny islands that are just barely out of the water. Now, before you think of moving there, think about what this is made of. This is all calcium carbonate, which means if you try and grow crops, they can only grow in soil that is calcium carbonate. Your vitamins, your nutrients, you're not going to be getting them. You're going to have to get them all out of the ocean, which is a little bit weird. That's why living on volcanic islands is probably a little bit better, because the nutrients cycle back into our bodies. Why did I show you this? Because this is a little bit weird. Back during these 1940s, we blew up a good portion of this island. We fought all over here, and we still have a base here. Here is Kwajalein, and here is that. Here's the highest mountain on the island, a pile of trash with a radar base stuck on top of it. Most of it is the airport, and it really is just a few feet out of the water. This is what it looks like from the side. So if you have a mountain bike, you're going to be kind of bored. However, everybody does have bikes there because that's how you get around. No cars for the most part. Only for the government officials. Now let's take a look at French Polynesia. This is Tahiti. This is Moorea. Take a look. This is an older island. Sorry, well, how do I put this? It's not as old as this because it's still got an island, but it's younger than Samoa. You have a fringing reef here. Here's Moorea, the island right here. And here is the reef growing outwards from this area. You can see sediments kind of washing out into the ocean after a big rainstorm. This is kind of cool. Off Raiatu, I stayed there for a week with a Tahitian family. But let's look right over in this area. In this case, the fringing reef is about 2,000 feet out. Over here, it's almost a half mile out. Now, if you remember earlier, I think we talked about currents. This is where the water comes on top of the reef and it runs back out of the reef in this direction. You don't want to get caught in this. I know, because I tried to swim from Club Med right here over to this island, maybe about a half hour. Couldn't do it. Swam, 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 and got nowhere. The current is too strong. Now, what is the ocean floor most? It's mostly plains. It's not just plain, it's plain. It's really flat. When James Cameron even went down to the trench, let's go back to the trenches that we were talking about a while ago. Even the trenches off here, the Mariana Trench right here, when he went down to the bottom of it, he said it's incredibly flat. They don't show you that in the movies. They expect you to think that it's really steep. It's not. A couple more things to cover. Along the eastern part of the Atlantic, hot plumes are coming up, splitting apart the Atlantic Ocean. Younger rock is here, older rock is here. It's higher along the ridge, lower here, so it's higher and younger, lower and older. Really thick sediments far away from the ridge, really thin sediments right next to the ridge. People didn't believe this was happening for a long time, but it really is. Iceland is where the Rift Valley actually peaks above the level of the North Pacific Ocean. On occasion, you get mountains forming along this ridge, but as this thing drops down away from the Earth's zit, essentially, which is what this is, you end up with seamounts. If they get worn off the top, they're called guillots, which is so French. And in World War II, people would hide their submarines by just resting on top of this. Ships would go over, you wouldn't be heard. Here is from Google Maps, and I should have you guys go into Google Maps and look at all this stuff. Here is the mid-ocean ridge going down the Atlantic. Here are the Azores or the Canaries, I'm not sure which one. And here's some mountains, some seamounts. Again, here's how an atoll forms. You have a young island like Hawaii, then it becomes more like Samoa, and then more like Tahiti, then eventually like the Marshall Islands, where it's nothing but coral. And the island itself has sunk back down. Wonderful diving. If you have a chance, go there. By the way, Kwajalein is in trouble. The ocean, despite what some news channels say, is rising. And this really is only about 3 feet out of the water. The good thing is, they're so close to the equator, they don't get hurricanes very often. So it's not a big deal yet, but in the next 50 years, it probably will be. Now, along those trenches, where you have the hot water rising, you have more water being brought through here, and you end up with all kinds of mineral deposition. Why is this cool? You get these things called black smokers, and you end up with manganese nodules. Very cool. Now, types of sediments. Anything that washes off the land is called terrigenous. Terra, earth, genus, forming from. There's also biogenous sediments. Things that extract salts from the water, and then these things die. They go down to the bottom, and you end up with feet after feet after feet, meter after meter of ooze. If it's rusty because it had oxygen in it, you end up with red ooze. And this is what it looks like. By the way, diatomaceous ooze comes from diatoms. If you buy DE or diatomaceous earth, it's the little skeletons of these guys, and we use it in swimming pool filters. And we also have hydrogenous sediments. Iron and manganese can be forced by pressure and chemical reactions out of the ocean water and onto the bottom of the ocean. And we have these nodules on the bottom that we are thinking about mining. That's the end. Thanks for listening. I know, it's so distasteful. Sorry, but it's also kind of funny.